Good afternoon, or good morning, or good evening, where we are for this EuroStruct webinar. This is going to be the last EuroStruct webinar in this semester, and we are very excited to have today Hoda Azari with us. But before introducing Hoda Azari, I would like to introduce myself. My name is Rade Hajdin. I'm President of Infrastructure Management Consultants, a company in Zurich, Switzerland, and at the same time I am a professor at University of Belgrade, and it's really an honor for me to moderate today's webinar. My co-moderator is Irina Stipanovic. Irina, would you like shortly to introduce yourself?
Thank you, Rade. So I'm also a visiting assistant professor at University of Twente in the Netherlands, and also the owner of the company in Croatia, Infraplan Consulting, similar to Rade, and also dealing with infrastructure management problems. I'm very happy to co-host or co-lead today's webinar.
Thank you very much, Irina. And our today's guest is quite a prominent guest, I may say. Dr. Hoda Azari is a Federal Highway Administration, U.S. Federal Highway Administration Non-Destructive Evaluation Research Program Manager. So it fits very nicely to our topic. She is structural engineer holding a master's degree from Sharif University of Technology in Iran and holding PhD University of Texas in El Paso. She was, I understand, postdoctoral also in Texas, right? At University of Texas at El Paso after joining the Federal Highway Administration. She has over 10 years of experience in non-destructive evaluation and structural health monitoring of highway infrastructure. She has done extensive research studies on condition assessment and damage detection of transportation infrastructure and performed forensic investigation services to state DOT. Dr. Azari is the lead of the SHARP Bridge and Tunnel Project. She is also the Federal Highway Association Administration Technical Point of Contact for application of unmanned aerial systems, augmented reality, and artificial intelligence in highway infrastructure. So something that is very cutting edge of research today, and we are very excited to hear much more from that. Irina is going to give a short abstract of today's talk of Hoda, and then after that, the podium is yours, Hoda.
So Hoda will tell us or give us a comprehensive review of current practices and policies of using non-destructive evaluation technologies to complement the historic visual inspections. She will give us the identification of successful and unsuccessful case studies on concrete, steel, and timber bridges for the effective and ineffective use of these NDE technologies to meet bridge management policies. Challenges and lessons learned in this implementation of NDE technologies in each state will be discussed. Hoda, we are looking forward to your lecture, and the podium or the floor is yours.
I'm sorry that I have to intervene. I forgot something. Then after that, you can start. Hoda, I have to put some rules here. I have to say that this talk is going to be recorded, and pending the approval for Federal Highway Administration would be also published on YouTube. I would like to acknowledge University of Minho, FIB, and Butik for supporting these EuroStruct webinars. I would like to indicate that you should switch off your camera and microphone. If you have any questions, please post them at the chat to the user EuroStruct Association. Now, no further ado, Hoda, please.
Thank you. Good afternoon and good morning, everyone. Thank you, Dr. Rade and Dr. Irina for the introduction, for inviting me to this webinar series. I'm Hoda Azari with the Federal Highway Administration. I manage the NDE research program. It is my pleasure to be here today and share with you how 10 states in the United States use and evaluate and implement NDE technologies. So historically in the United States, State Department of Transportation or state DOTs have relied primarily on visual inspection to evaluate the condition of bridge decks. For suspect areas identified during the visual inspection, engineers use hammer sounding and chain dragging to further evaluate potential subsurface damages such as delamination. And as you know, delamination happens when de-icing materials and water penetrate the concrete bridge deck down to the steel rebar, and the steel corrodes until it forms corrosion products on the rebar, and then it cracks the concrete along the rebar mat, resulting in spalls and delamination. Well, it is simple, but it is subjective, the visual inspection. It's only sensitive to advanced deterioration. So it is sensitive to the size of delamination. And it only detect very extensive delamination, not the early stages of damage and delamination. So advances in NDE technologies have enabled state DOTs to save inspection time and better assess the actual condition of bridge decks. We recently conducted a comprehensive review of current practices and policies of those states that are using NDE technologies to complement visual inspection. So our overview primarily addressed bridge decks and bridge deck inspection, and how bridge owners in 10 states use NDE technologies. And you can see the states on the map, and how, so this presentation is about how these 10 states use NDE technologies to assist them with managing their bridges and their assets more effectively. So as part of this research process, each state also answered how can FSWA can help the states with NDE knowledge and more NDE implementation. So before I go to the states and the current practices of states, I will go over the most common NDE technologies used by states. So one of the most commonly used NDE techniques by states is GPR, ground penetrating radar, which uses electromagnetic wave pulses in the microwave band of the radio spectrum to image the subsurface features in the bridge deck or in pavement or tunnel. So the radar reflections from inside the material are then imaged for evaluation the condition of the medium. So GPR, as you may know, can be ground coupled, or it can be air coupled. It can be attached to a vehicle and move as a traffic at traffic speed, but it provides lower resolution in exchange of speed compared to ground coupled. Another common NDE technique is infrared thermography, which images the temperature of the subject and the flaws in the bridge deck or tunnel or pavement. It cools and heats at different rates. So it provides a surface image of the location of the flaw. And the last, one of the most commonly used NDE techniques by the states is impact echo, which is an acoustic based or stress wave based NDE method in which stress waves are transmitted into the material or the medium, and then reflected back from the flaw or delamination or damage. So now we move to the states. First one is California. While California DOT, which is called Caltrans, is researching and starting to implement newer NDE technologies, the agency's bridge deck inspection primarily is visual inspection. Like the most state DOTs, Caltrans supplements its visual inspection with some visual aids like spotting scopes. And as a follow-up to the visual bridge inspection, they do hammer sounding and chain dragging to future evaluate like suspect areas. They have some high speed inspection program in place for pavement inspection and crack detection. They have cameras to collect images, surface images of pavement and bridge decks. And then they apply artificial intelligence technology to identify details like crack location, crack width, and the density of the crack on the surface. So they indicated that the program is highly effective, especially in urban areas where it is difficult to close lanes for visual inspection. Caltrans is also employing some advanced NDE techniques like infrared thermography and GPR. They reported that the air-coupled GPR enables an increase in the data acquisition speed up to 50 miles per hour, which is around, I guess, 80 kilometers per hour. But however, it's not appropriate for every investigation. It depends on on the application or the target of investigation. The agency also investigated automated hammer sounding. This technique was faster than the conventional hammer sounding walking speed, which yields similar results to chain dragging, but it's at higher speed. So the main advantage is that they can do it at like 20 miles per hour for the lane closure perspective. Instead of the full lane closure, they can do it at a faster speed. And in terms of barriers to NDE implementation, Caltrans indicated that the primary limiting factor is resources. With the number of bridges in California, current application of advanced NDE technologies are better focused on project level application or investigation for known problems. They are not currently using technologies for all the bridges, just on project level. And it's not routinely using GPR, IR, or any other NDE technologies for bridge deck evaluation or inspection. So it's just for the known problems. The agency indicated that a GPR is a good tool, but it requires significant training and experience to use it effectively. And similarly, IR is helpful, and it's a complementary tool to GPR. But again, it needs they need some internal development to deploy these technologies. Other NDE techniques such as impact echo, they're not quite ready yet for broad implementation, and they indicated that they would like to see improvement and enhancement in existing NDE techniques. So they would like to see more research to make NDE methods more economical to use and less subjective. They indicated that they need to be less complicated and more simplified processing, post-processing of data, so that they can use NDE routinely. And to answer the question, how can FSWA help? When asked, they noted that there seems to be a core group of states implementing these technologies. So it would be good to bring states together to share their experience, exchange information, exchange like lessons learned, so to develop a core experience and apply best practice and transfer knowledge. Also noted that unbiased assessment of the effectiveness of various NDE method is very important and is very much needed. The next state is Colorado DOT or CDOT. They have applied technologies like infrared thermography and LiDAR to initially scan the tunnel lining. So they run these two methods at traffic speed up to 35 miles per hour, or about 60 or 50 kilometer per hour, so that the tunnel could initially be inspected much faster than manual inspection. And where the IR technology identifies a potential problem, CDOT manually investigates with conventional tunnel lining inspection techniques of visual inspection and like tapping and hammer sounding. The agency found that the time required to collect and correlate and analyze the data was not necessarily cost effective relative to the information that is obtained by conventional visual inspection, and noted that some data analysis repeatability have some like issues and concerns. Correlating images to correct location was time consuming and cumbersome. So these were like challenges they noted. For bridge deck inspection, CDOT starts with a visual inspection and uses chain dragging to further investigate the suspect areas. And because NDE inspection provide the bridge inspectors with more detailed information about the condition of a bridge, CDOT looks at the NDE results when rating the bridge. For inspection prior to a bridge deck rehabilitation, they employ chain dragging and GPR to help with rehabilitation quantity estimates. Right now, they don't have any NDE technology investigation in their plan, but they noted that they keep up with the latest NDE development through vendors, other states, in conferences, to better understand different applications with NDE and to better understand what other states are doing with NDE. And how can FSWA help CDOT with the NDE knowledge and implementation in Colorado? So when asked, they responded that they always try to be up to date with the new technology. So peer exchanges, information sharing would be valuable for this effort. And they caution that while new technologies offer some useful application, it's not always the most cost effective solution. So we shouldn't, or Federal Highway shouldn't be forcing new technologies on the states. They noted that the states should determine if and when NDE technologies are the most cost-effective option for a particular project or a problem. The next state is Indiana, Indiana DOT or INDOT. They have scanned over 200 decks using air-coupled GPR. The agency used the NDE results to assist engineers with programming, decision and managing their assets, bridges, and to predict when and where problems can happen, and to define deteriorated areas, including delamination. So while INDOT does have the ability to conduct NDE by themselves, they have found that consultants bring much more experience, and sometimes they apply a proprietary software that does a very good job. They prefer to go to the consultants instead of relying on their own resources. So the agency enters the results, the NDE results, into a database, and bridge inspectors use that information as part of their condition rating process. They use NDE data to develop deterioration curve and to make decision about whether to repair or replace a bridge deck based on the NDE data. For future plan, they indicated that INDOT is conducting future studies with IR and Impact Echo with the intention of developing project level and network level NDE programs. Then how can FSWA help further NDE knowledge and implementation in Indiana? So they noted that more emphasis should be given to support practitioners on how to best apply various NDE technologies, including the collection, interpretation, and the management of the data. And they need recommendation to address variables affecting the NDE data, such as state, geographies, weather, different types of treatments, and aggregates in different states. The next state is Iowa. For bridge deck inspection, the Iowa DOT employs sounding as their most widely used technique. And they indicated that they get repeatable and understandable results from sounding. While almost all of their inspection are done manually, Iowa DOT has also investigated some automated hammer sounding system to speed up the inspection. The agency concluded that while it doesn't necessarily save money doing the automated inspection, they can complete the inspection much faster. They did some validation tests like coring, and they found that the results from the automated sounding reasonably match with the manual sounding. And they found that Impact Echo to be the most reliable method for inspecting concrete bridge decks with overlay. And they found that the validation testing, such as coring, is the key to determine if an NDE technique does what consultants and manufacturers claim. They believe that NDE can help in planning and decision making, but they have not done any return on investment analysis to quantify the added value of NDE. So when asked how can FSWA help, they reported that more work to evaluate the effectiveness and validation of various NDE methods is necessary. They welcome advices on how to pick the most suitable and the best NDE system based on their particular inspection problem. The next state is Louisiana. Louisiana DOT or LA DOT has experienced a culture shift toward the use of NDE technologies. They believe that chain dragging is an aging technology, and only more experienced inspectors still use it. And actually, the new generation of inspectors does not view chain dragging as the best technique. And one reason is that LADOT has the third highest bridge deck area in the country. And with such long bridges, some more than 17 miles, which is around 30 kilometers long, it's not practical to chain drag all the decks. So the agency has moved toward NDE, and they rely heavily on NDE techniques to help them identify potential problems within the bridge deck. They use high-speed GPR and IR to minimize the lane closure and as a way to prioritize which bridge decks need work. So they noted that NDE technology is improving. Like high-speed GPR deck used to be limited to around 30 4 miles per hour, and now inspections are performed up to like 60 miles per hour. They also noted that their NDE application are working well. Program managers use NDE data to plan repair breach decks. They currently don't use NDE results as part of their condition rating, but they would like to pursue this capability and investigate the possibility. Regarding the use of advanced NDE technologies in the state, they're evaluating UAS or drone for bridge inspection. And when asked how FSWA can help, they indicated that FSWA could increase NDE knowledge and implementation in Louisiana by defining what NDE personnel requirements and qualifications should be, and how to correlate NDE data to bridge element condition rating. The agency also is interested in learning about advances in NDE technologies and their best application, where and when it is best to apply NDE. Next state is Nebraska, Nebraska DOT or NDOT. They reported that they do NDE in collaboration with a university, and they completed some field implementation with the university level research. The inspectors routinely use visual inspection, and if the visual inspection indicate a concern, NDOT perform chain dragging or a more in-depth inspection. They perform advanced NDE, not in a regular basis, only when at the project level, only when a problem exists and they want to locate the problem. They hire outside consultants for all their advanced NDE For example, they conducted GPR and IR imaging on different bridge decks with a team from university. The fun fact is about NDOT is that the majority of their bridges are overlaid, are asphalt overlay. So their primary objective of using NDE is to determine what NDE methods work on overlay decks, which especially on asphalt overlay, which is limited number of NDE technologies work on asphalt overlay. So that's one of their like implementation barriers of NDE, and their primary objective of using NDE is like finding the best NDE method that works on overlay decks and estimate the quantities for rehabilitation. And overall, they indicated that they were satisfied with the technology performance at estimating quantities on asphalt overlay, but they had some issues with like infrared thermography to detect damages on the asphalt overlay. They have not done any return on investment analysis, but they believe that NDE saves money by more accurately estimating the range of work. Actually, they indicated that they have 2 years of bridge deck evaluation data that they can analyze the data to see if it correlates with the lower cost.
I can't hear Hoda. Can you hear Hoda?
No, I cannot hear. No, I thought maybe my side, but it's not.
Hoda? No.
We don't hear you. No, all of a sudden. Sergio is not on our side, right?
No, it's not from our side.
No, unfortunately not.
What about now?
Yes.
Yes. Yes.
Okay.
Great.
Let me stop my video. Maybe it's the bandwidth.
Maybe, yeah.
I suppose we can continue since there's just one problem. So we'll try to follow up.
Okay.
It's not in presentation mode now, but
Sure.
yeah.
Okay. Can you see it well now?
Yes, great.
Can you hear me well?
Yeah, I do hear you. Yes.
Okay, perfect. So
The last thing you said is that you know that you started this slide essentially state CO2 experience Nebraska and it's saving money.
okay, perfect. So yeah, they haven't done any return on investment analysis, but they believe that NDE data can save money, and they have 2 years of data that they can analyze to do the return on investment analysis and see if NDE data has actually, or NDE has saved any money, or if it costs them more because the repairs were because the performing the NDE technology was too expensive. And when asked how FSWA can help them, they noted that some NDE methods are easy to understand and interpret, and some are challenging. And the agency does not have the training to interpret the NDE data. So they asked for some assistance from FSWA in the area of like data analysis and better understanding NDE technologies. They found it to be helpful. They, like I said, they currently rely on consultants and they cannot do a good job on quality control of the inspection process. So they would like to rely on FSWA to do a quality control and to help them better understand the data and the technology itself. So the next state is New Mexico DOT or NMDOT. They primarily use NDE to follow up on suspected areas identified in visual inspection. They reported that it employs NDE methods to help managing the bridges on a project level, as well as finding problems that need repair and to establish projects to fix the problem. So they use NDE results to help them with the decision making on whether to preserve, repair, or replace bridge sections. They identified a number of factors as barriers and challenges, obstacles to implementing more advanced NDE techniques, like difficulty to access all areas, traffic control, resistance from users, because some of the users, they are uncertain about the usefulness of the data. Variability of results between inspectors, but overall, they indicated that they had some successful NDE application, which resulted in more precise results compared to chain dragging. One point that they mentioned was that, for example, GPR is not a magic bullet. It offers value when applied appropriately, and it can help determine whether a deck is a candidate for preservation versus replacement. They noted that they found GPR works well as a first pass, but a second, more in-depth scan or a more in-depth technology is necessary to produce more detailed results that is critical for decision making, whether to preserve, replace, or repair the deck. For overlay inspection, NMDOT indicated that chain dragging is the most reliable technique to detect the bonded overlays. It seems to work in seeing through asphalt and epoxy overlay, but does not appear to do a good job with the latex modified concrete. How can FSWA help? They indicated that FSWA could contribute to NDE training and education opportunities, particularly because of the turnover in NMDOT staff and lack of internal resources. They also need assistance to get information about advances in NDE technologies through webinars, videos, peer exchanges, meetings, etc. And finally, they indicated that it will be important to keep expectation reasonable when comparing NDE lab performance and real-world NDE performance. Oregon DOT or ODOT reported that they extensively employ chain dragging on concrete decks, and they use magnetic particle inspection, ultrasonic inspection on steel bridge elements. After performing some experimental project using advanced NDE methods on concrete, the agency concluded that chain dragging will perform the same inspection as the more advanced NDE method and do it faster and cheaper. They felt that manufacturers oversold the capabilities of some of the advanced NDE technologies, and the NDE techniques, they don't necessarily do a good job at detecting delamination compared to chain dragging. They noted that they had some successes in the area of structure health monitoring. They monitored about 13 bridges with known and existing problems. They monitor some bridges for just a few months and some for about like 20 years using strain gauges and displacement transducers, and they had successes in detecting the problems and the source of the problem. They also noted that NDE results do not directly tie into the condition rating of bridges because the NDE results are, they found it difficult to correlate NDE results to the bridge condition. And their primary issue was like interpreting NDE data and correlating it with condition of the bridge. As for future plan, they plan to assess the cost of hiring an NDE consultant to scan a bridge deck to help estimate the extent of the required repairs. And they would like to compare the cost with the case that either they don't do NDE or they rely on their own resources, internal resources to do the NDE. And when asked how can FSWA help, they responded that the procedure to take large amounts of raw data and process it to a point where it could be used to manage an asset is too difficult, and it is inconsistent between the operators. So they noted that although there are like ASTM standards to collect the data, the data processing side is inconsistent. So they feel that a universal reference and standard could be created to make the tests more repeatable. The next state is Pennsylvania, or PennDOT. They reported that they primarily use visual inspection on bridge decks, but they have some NDE data such as DPR, GPR, and infrared thermography data to manage their bridges and tunnels on a limited basis on specific projects to help with decision making. They mentioned that uncertain accuracy in the NDE results and the time and cost involved to get the final NDE results are the main challenges for implementation of NDE on bridge decks. They use GPR to scan bridge decks and help with planning the type and amount of rehabilitation or repair work. And they concluded that GPR can be effective, but only on certain bridge decks and in certain circumstances, because getting bridge deck deterioration information takes a lot of analysis after scanning. So the data analysis is a challenge for them. They would like to see a standard GPR procedure for data analysis, data presentation and reporting. Also, standards on the setting the equipment, better accuracy in rebar identification, aspect of the software. And also they would like to see more cooperation between academia and equipment manufacturer. They also performed some tunnel inspection using NDE. The goal was to demonstrate and evaluate the ability of handheld NDE methods and high-speed mobile scanning methods, such as air-coupled GPR and vehicle-mounted infrared thermography to detect deterioration and the tunnel lining. They also tested a traditional physical inspection technique like hammer sounding and coring in some limited cases to evaluate the highest speed NDE results. So they concluded that no single technology by itself can provide all information they need to assess the condition of tunnel lining. They believe that the best application for NDE technology is to use one or two NDE method in combination with traditional hammer sounding. They noted that while GPR correlated well with hammer sounding, it doesn't seem to be a practical solution over traditional physical method for visual inspection because of the cost and time required for data processing. But they also noted that the cost and time may be reduced significantly during subsequent NDE inspection because the test procedure is already established. So the cost would be decreased in the future inspections. In the tunnel IR testing, they found that it's difficult to obtain reliable and useful results from tunnel liner because the surface of the liner is not directly exposed to the sun for like active heating and cooling cycles. So they noted that IR may be better suited to detect moisture-related anomalies in which the evaporative cooling is detectable using the camera. They indicated several obstacles in implementation of NDE technologies, including the cost and uncertain accuracy of NDE results. So they think that sounding is still required. The software used to process and analyze the large amount of data is not user-friendly, and an experienced operator is required to run the software. For example, they brought an example that they received an estimate of 2,500 man-hours to convert digital photogrammetry data into drawings. And it takes about 7 months for PennDOT, sometimes, not always. Sometimes it takes about 7 months to get the final NDE report. So the timing doesn't work for them. And when asked how can Fswa help, they indicated that they would like to receive more updates about like new NDE technologies, learn about what other states are doing. So they think in exchange of information, those type of webinars or meetings would be helpful to learn about other states. And the last state is Virginia, DOT, VDOT. Again, they primarily rely on visual inspection. When visual inspection indicates significant corrosion deterioration, they employ more in-depth methods such as chain dragging, sounding, and half-cell potential. They have also used more advanced NDE techniques like GPR, IR, and impact echo ultrasonic tomography if there is an application, but not on a regular basis. WDOT's work on evaluating advanced NDE techniques concentrates on two areas. The first is the rapid screening of a bridge deck to quickly assess the condition without the need to close lanes. And the second area or second phase is using NDE to help determine the extent of damage to a bridge deck. So this is a kind of information that becomes valuable in making a repair decision, estimating damage progression rate, and to better estimate and plan repair material quantities. WDOT evaluated GPR, IR, and high resolution imaging NDE technologies on 25 bridge decks. They inspected a few of the suspect areas with more thorough handheld GPR and with impact echo, and they noted that the results correlated well with routine inspection. They also performed NDE research in several other areas, such as time-lapse, IR, and magnetic flux leakage inspection. So the MFL, or magnetic flux leakage, is a method where a magnetic field is introduced in a steel cable or tendon, and then the magnetic field sensor are used to look for leakage that represent potential underlying damage. These are not routine inspection, and they are only used for a few special investigations. For example, WDOT noted that they employed a magnetic flux leakage NDE system to inspect some post-tension tendons with some potential problems, that they got good results and verified the technology in the lab on a few mock-up tendons with pre-built defects. And again, they found excellent correlation. They also reported that their approach in applying new NDE technologies is to conduct research first and then perform some trial projects on the more promising technologies, and finally look for the best potential application of the technology. The agency usually performs initial implementation of the new technologies with the consulting companies. So they want to implement the new technologies to reduce the lane closure and save money, but they first need to validate the technology performance and then go to like enhancing the technology. There were many cases that WDOT reported where they saved money. In one example, initial tests showed that there may have been an issue with the cover depth of the reinforcing bar, and the more detailed scan with GPR revealed that the entire top rebar mat had sunk due to the misplacement, and it left a thick, unreinforced layer of concrete at the surface. So the contractor replaced the entire deck before the bridge was put in service, which avoided future problems and it saved cost. And finally, when asked how FSWA could help WDOT, the agency stated that open communication and discussion help states to keep up with like what NDE technologies are being used and what new technologies are emerging for potential future application. So in summary, our review provided a snapshot of how 10 states use and evaluate and implement both basic and more advanced NDE methods as part of their bridge inspection and management program. All states have applied NDE techniques at some level. Several of the sample states have successfully established advanced NDE technology. for example, Indiana and Louisiana, have both improved their ability to efficiently manage bridge deck maintenance and repair through new NDE programs and processes. The traditional chain dragging technique is still the primary way of inspection in most of the states. But NDE technologies, especially those that are at traffic speed, like GPR and IR, have enabled some states to dramatically improve the value of NDE information and inspection efficiency. We provided states with an opportunity to identify where they see gaps between NDE knowledge and implementation, and where FSWA can focus support to close the gaps. So we at the Federal Highway NDE program thoroughly evaluated and prioritized these recommendations from the states to ensure that the goal of the NDE program, that the NDE program, not the goal, the NDE program is addressing the needs of the states. So we recently published the NDE program strategic plan that has incorporated the state's needs. This strategic plan consists of 3 goals and objectives and a list of strategies to meet these objectives. So the first goal is related to stakeholders to enable effective application of NDE technologies. And the second goal is technology related. And the objective is to improve the accuracy, reliability, and benefit of NDE technologies by developing new technologies and improving existing technologies. And the last one is related to implementation. And the objective is to support implementation of deployment-ready technologies and have accelerate the implementation of market-ready and reliable NDE technologies. As you see in the picture, there are 14 strategies identified, and we are now developing a strategic roadmap that outlines short-term, medium-term, and long-term activities that can be carried out over the next 10 years by FSWA to increase the maturity and growth of NDE for highway infrastructure and to maximize the return on investment of the technology. So before I conclude my presentation, I would like to use this platform and bring your attention to the FSWA NDE webinar series, which is held on the last Monday of each month at 1 p.m. Eastern Time. If the time is a challenge for you to attend, all the webinars are being recorded. So if you're interested to be added in the distribution list, even if you cannot attend the webinar on time, please contact me directly and I will add your contact information to the distribution list. And please share this information and the meeting invite with anyone who might be interested in this topic. So the webinar is about sharing state DOT's current practices, current projects, challenges, and best practices. So in these webinars, in each webinar, one state DOT will be sharing their motivation to use NDE, their implementation challenges, a few case studies, and their future vision and recommendations to other states. So I encourage everyone to attend this webinar and to share the information with your colleagues. That is all I have for today. This is my contact information in case you have any question or if you need any information about the FSWA NDE program, or if you want to be added to the distribution list. Thank you.
Thank you very much, Hoda, for the interesting talk here, in particular because it was, at least for me, a little bit of sobering experience listening to you. Before we start with the questions from the audience, I allow myself to pose the first question, and look into my notes here. I realize there are two things that most of the DOTs would like to have, and this is the unbiased evaluation. In 4 cases, I noticed that, and there is also the need to help with regard to education of the people in DOTs to use NDEs. I guess these two things might be a bit connected to a certain extent, because if you increase education, then might be that the unbiased evaluation will be much easier than if you have people that are not really familiar with NDE techniques. What is your take on that? And are you trying to do this unbiased evaluation as well in order to prevent, selling people things that are not really useful?
Yeah, that is absolutely right. And I agree with you. Those are very much connected, education and unbiased evaluation. One way that we are doing like the unbiased evaluation, it's not unbiased evaluation, it's more on the education side, is a website called Nde Web Manual, which help the practitioners and asset owners, basically those who do not have a good understanding of NDE, and we help them with the selection of NDE technologies based on the type of infrastructure, the type of element, the material, and also the target of investigation. It's like a tool that you make selections from the type of infrastructure, the material, the elements of the bridge, whether it's a deck or it's a superstructure, substructure, and then the target of investigation. It can be different types of defects, or it can be measuring the thickness or the rebar depth, etc. And then after you make all these selections, the recommended or the most appropriate technologies they pop up in a separate box. So that is one way to help states better understand NDE. It has all the information about NDE technologies in very simple words, how to acquire the data, how to interpret the data, how to present the data. So it gives them like basic information about NDE and what technology to select for their specific problems, so that it's one way to help them not being oversold by vendors and manufacturers. But more education is needed. Absolutely. We have a Federal Highway offers a course, an online course, a virtual-based training course for NDE. Again, it's very basic. It doesn't go into like detail and technical detail of the technology, but it provides like a general information and understanding of the technologies. But absolutely, more information, more education is needed in order to more implement NDE.
Yeah, you need a pilot if you want to operate the airplane, right?
Exactly.
Irina?
I wanted to ask you, I have also one question from the audience, but before that, so the cases or the techniques you have presented are for the bridge decks from the top, let's say. So we talk about concrete bridge decks in this case. So how do you inspect the substructure elements, let's say, and the decks from the bottom? So is that included, or what techniques do you use?
Yeah, that's a good question. The survey or the review of the current practices and policies in state DOTs only focused on bridge decks and inspecting bridge decks from top. But sometimes, because of the overlay and the challenges with applying NDE on overlay, we have investigated in a separate project. We have investigated inspecting or using NDE technologies from the bottom side. It can be used in cases, but it doesn't. Some of the technologies like infrared does not go deep. So if you inspect the bottom of the deck, you miss the delamination on the top rebar mat. So those are some challenges if you ever decide, or if you have to use NDE from the bottom side, but in some cases you have to, there is no other choices. And in response to your other question about the substructure, there are some common technologies for substructure, and there are some different technologies. But basically, you can use the same technology you use on the bridge deck. It's the same physical principle. It's just a matter of getting access to the elements for the substructure. And yeah, but the review of the current practices was mainly focused on the bridge deck because this is the area which is more used or more have been investigated by the states is the bridge deck. So we focused only on bridge decks and we didn't go further, but absolutely that would be the next step.
I have one question from the audience. Shall I go? Okay.
Yeah, go ahead.
So we have a question from Mahdi Ahmadwand, and the question is, have you actually compared the results between NDE data and how accurate and reliable are between each other? So.
Yes, we have some pilot bridges that we have tested as part of the long-term bridge performance program. They have used multiple NDE technologies, and they've compared some of the NDE technologies that are comparable, because not all of the technologies are comparable, because each technology is a different physical principle, and it's good for detecting a special type of defect. But for example, in one case, we could see delamination through impact echo, and we could see corrosion or the potential corrosion with electrical resistivity of Fswa potential. And there is a very good correlation between the impact echo map and Fswa potential map, although they represent two different physical principles and they can detect different types of defects. But we could make a conclusion that the delamination is caused by corrosion, because we could see the corrosion. There was a good correlation between corrosion and delamination. So that was the conclusion, that the delamination is caused by corrosion, because not always delamination is, it can be caused by heavy traffic. But in that case, it was caused by corrosion. So yes, we have done some pilot projects and some pilot bridges through the long-term bridge performance program, and we got very promising results on those bridges.
Thank you, Hoda. I have another question actually two questions, but one of them is already answered, I believe, for Sikandar Sajid. I'm wondering if any DOT uses the impulse response test either by themselves or through consultants. That's question number one. Number two, any DOT uses any accuracy benchmark, which we just addressed, when selecting specific NDT? From what I see so far, the speed of the testing in there is their main benchmark for selecting a specific NDT method. This is an assumption, and you might want to answer these two questions.
I go to the second question or comment first. Yes, that's right. That would be their main goal, to get NDE technologies that doesn't need traffic speed. But again, it depends on the problem and the application. In some cases, they go into the more detailed or in-depth investigation using, for example, impact echo. But on a network level, yes, high-speed technologies is preferred by states. And going back to the first question, impulse response, I'm sure they do, but on a very limited basis. They haven't mentioned in our survey or interview with the states, they haven't mentioned impulse response. But again, I'm sure that depending on the application, they have used impulse response on a very limited basis.
Irina, question on your side?
Yes, I have a question from Jan Wunderlich. So the question is, actually, we have seen different inspection methods and who applies them. The question is has there been any quantitative cost benefit or, for example, benefit in the sense of risk reduction analysis performed to determine what is the optimal inspection method considering specific situations?
Unfortunately, no. There has not been any like return on investment or risk-based analysis to detect the most optimum NDE technology. Currently, we have a project. It's ongoing. We started it like 6 months ago, so it's very new, in which we are developing a return on investment tool to evaluate and quantify the added value of NDE. So that would be of interest. It might be of interest to you, but even states have not done any return on investment on their side, and there is no research done in this regard. So this is something that we're working on. I know that this is a need to know what is the added value and return of investment when you use the technology, because everything is translated into money. So we are working on it.
Yes, the value of information, that's a point that is also dependable on the reliability of the NDE testing. And this is, as you just saw in your lecture, not always given. There is another question here, which I guess it's already answered by you, but you may give a second thought on that. What is your opinion on using magnetic flux leakage? You mentioned that in Virginia, I believe, for pre-stressed girder and wire ropes and cable and suspension bridges. Is there any interest to introducing this? I guess it is already introduced, so please. Maybe you have some more information.
Sure. Some states in the United States have corrosion problem. So like Florida and Virginia, so they have used magnetic flux leakage. And I know that they have got promising results from the system. We also evaluated the technology in the lab, and we got promising results in the lab setting. We haven't validated the system in the field. But as far as the lab setting, we got promising results to detect and quantify the corrosion in pre-stressed girders. And we built a robotic platform that can carry the magnetic system along the girder. So yes, both Florida and Virginia, those are the two states that I am aware that they have used MFL, that they have had successful results from the technology.
Irina, your question?
I have no more questions from the audience. I wanted to ask another maybe question.
But I have a couple.
Okay, then you go. Go.
I'm sorry for that. The question, actually two of them. The question come from Hannah Marty's sons to you, Hoda. She would like to thank for interest presentation, but it seems that from your presentation we not need to improve NDE methods, but presentation of results or visualization of results, if you want that way. Are their clients worried if they cannot be interpreted the data? They are not in charge of project and they lose control of it. How can this be improved? And this is really a very valid question in my view. If you have consultants that are very savvy and very knowledgeable, they may just overrule you. That's probably an issue.
That's very true. I remember in one workshop or conference, one representative from State DOT mentioned that we should work on data presentation like in the medical field. Like the technician in the medical field, the technician do the work, but the data is presented in a way that the doctor easily understand the results. So in this case, the technicians are, or the medical technicians are the vendors and the consultants, and the doctors are the asset owners. So the data should be presented in a way, intuitive, very intuitive, so that the owners can understand. Like the X-ray, when you provide the X-ray results to the doctor, he can easily detect a problem. But in case of our industry, highway industry, sorry, the results are not presented in a very intuitive manner. Mostly they are presented in a color-coded contour maps, but it's not very clear what to do with the data. What does the red mean, or the yellow mean, or what kind of action the asset owner should take based on the NDE data that is provided to them. So again, this is something that we're working on to help them make informed decisions based on the data, the information that is provided to them. And I'm absolutely right. You are right that you have to present the information in a way that is understandable. It shouldn't be so technical, so that the owners can rely on the information that you provide. So it's not above their head, it's within the level of their understanding, so that they can have confidence and they can rely on the data or the information.
Thank you, Hoda. I think we have already 20 minutes behind the schedule. I would there is a couple of questions still here, but maybe this question can be forwarded to you directly. Maybe or if you have some time, I can forward it to you. It's up to you, Hoda.
Sure, either way, you can ask me now or forward it later.
João Amado asks, any specific thoughts, recommendation on ultrasonic tomography, specific document, lessons learned, webinars, and so on?
Yes, we have used ultrasonic tomography on a couple of our projects. This wasn't a method that came up with in the interviews. So in some projects, I guess it's more research-based. I haven't seen any state DOTs using ultrasonic tomography, again, because it's time-consuming. But we have used it, and we see like potentials, and we have had like successful experience with the technology.
Irina, you wanted to ask the question as well, right?
No, it's okay. I think we have exhausted all that.
Okay.
That's okay. No, I'm very happy to be here.
Okay, great. So with not further ado, I would like very much to thank you, Hoda, for sharing with us the experience. Again, it was a sobering one, which is good sometimes, because every now and then we hear what everything is possible, kind of, Star Trek wise, but this is not still the case. So it's good to know what the state DOTs think about that. And again, thank you very much. And to all the participants, some of them left already, I see here. I would like to thank them for bearing with us to the end, and wish you all a very good summer and stay healthy. And Irina, maybe your last word.
I will follow what's happening on the EuroStruct website. So we are coming from EuroStruct Association, and the live talks were organized from EuroStruct. So there will be a new plan for the, let's say, new academic year. So, and we have a conference at the end of the August, but the more information is at the EuroStruct website.
Great, I appreciate that. So take care, everybody. Thank you very much.
Thank you. Thanks for inviting me.
Thank you for coming.
Bye-bye.